Today we are going to learn about simple and compound interest. First of all, you need to know that interest is money paid for the use of money. This is important because it's something that works both ways. If you're borrowing money, you're going to pay somebody that money back. If you are saving money, they're going to pay you for the use of the money. So interest can be good for you or it can be bad for you. There are certain words that you need to know, and they are listed here in our notes. Principal is money saved or borrowed. Rate is the percent, and we always want to use that as a decimal. And then time is talked about in years. Could be 2 years, could be 5 years, could be 1 year, could be semi-annually, which is half a year, which would be 0.5. Quarterly is 3 months, which would be 0.25, and so on. If you have 4.5 years, you're going to use 4.5. We want to be able to find simple interest. And when we say simple interest, that means you are charged one time for interest. So this can be a really good deal. If you borrow money from your parents and they say, okay, you can have this $200, but I'm going to charge you 7% and I'm going to give you 2 years to pay it back. That would be an example of simple interest. And to find that, we just use our formula, I equals PRT, meaning our interest is going to equal principal times rate times time. So for this first one, we would take interest is equal to 200 times our rate, which is 0.07, times our time, which is 2 years, so times 2. When you do that multiplication, you get $28 because 200 times 0.07 times 2 is 28. When you do that, then this is how much you're paying in interest. But if you're going to pay your parents back, you not only have to pay them the $28, you also have to pay them the $200. So you pay them a total of $228. For example 2, we have principal of $870, an interest rate of 6%, and a time of 9 months. 9 months is 3/4 of a year, so we're going to use 0.75 for that time. Interest rate is 6%, so that's 0.06. So when I'm going to find the interest for this, I'm going to say interest equals 870 times 0.06 times 0.75. When you do that multiplication, you get $39.15. Now, if there happens to be extra numbers, you always want to round to the nearest cent at the very end. So we want to say $39.15 is our interest. How much money are we paying back? We would add 870 to 39.15, and we're going to get $909.15. That's our total. Simple interest is just that. It's simple. It's a one-time interest. Compound interest is what you're most likely going to see in real life. You add interest to whatever it is that you're doing, whatever part, however many times it's compounded. So if I compound interest annually, that means it's once a year. If it's semi-annually, twice a year. Quarterly, 4 times a year. Monthly would be every month. Most things that we borrow money for, like credit cards or car loans or mortgages, they compound interest daily. And there's a whole table that you can look up and you can see how much interest is going to be. But what we're going to do is try and simplify it a little bit. On this next example, we're going to compound the interest annually. That means once per year, but we're doing it for 3 years, so that means we have to do it 3 times. We're borrowing $3,000 at 4% for 3 years. So the first year, we would take 3,000 times 0.04 times 1 because it's only been 1 year. When we do that, we get $120. That means we'd have $3,120 at the end of that year. Now, if this were a loan, we'd be borrowing. If it's savings, this could be how much money is added into our savings at the end of the year. So at the end of the year, we'd have $3,120. The thing is, with compound interest, is for the next year when we go to figure interest, we start not with the 3,000, but with the 3,120. So 3,120 times 0.04 times 1, that's going to give us 124.80. So now if I add that back in, I have $3,244.80. And I guess I should have put my dollar signs in there. Okay? For the third year, we want to go back to the next balance, which is $3,244.80. I multiply that by 0.04, I multiply that by 1, and I get $129.79. When I do that, I'm going to add that back onto my previous amount, and that's going to be $3,374.59. If this were a savings account that we were talking about, at the end of 3 years, instead of having just $3,000, we'd have $3,374.59. There is another way to figure compound interest that doesn't require us to do this many steps. However, the formula is a little bit more complex. So if you take a look at the next page there in our notes, it says we have B equals P times 1 plus R to the nth power. What a mess that is. But it's really not that hard. You have to take a look at what it's talking about. B is the final balance. Of course, P is the principal. R is the interest rate. And N is the number of interest periods. How many times you would do the simple interest for the formula. So you have to think about that a little bit differently. The example that's done for us here is $500 at 3% compounded semi-annually for 3 years. Semi-annually means twice a year, so that's every half year. So our P is 500. Our rate is 0.015 because 3% compounded semi-annually, that means twice a year. So you don't get the whole percent both times. You get half of it for the first time, half of it for the second time. So you have to figure out how it's compounded to figure out your rate. So 3% divided by 2 is 0.015. That's the rate we're going to use. Then we're going to have 6 times that we're going to do this because we're doing 3 years and it's twice a year. So 3 times 2 is 6. All right, we're going to take that. So we would put, well, I got to use the right thing here. Just like I were really here, right? We're going to have B equals 500 times 1 plus 0.015 to the 6th power. Now, when you do this in a calculator, you're going to want to be very careful because it depends on if you have a scientific calculator or not. You need to do the 1 plus 0.015 first, Do that to the 6th power and then multiply by 500. When you do that, you're going to get $546.72. And of course, you always want to round to the nearest cent. So, and I don't remember if this one rounded or not. So, all right, let's take a look at these next ones. Example 1, $495 at 8% compounded annually. That means we don't have to change the 8% for 2 years. So when I put this in the formula, it's going to be B equals 495 times 1 plus 0.08 squared. When I do that, remember 1 plus 0.08, square that, times 495, I should get $577.37. Okay? If I look at example 2, B equals, my principal is $2,000. It's 5% compounded semi-annually. That means twice a year, which means I'm going to have to take 5% and divide it by 2. So when I do that, it's going to be 1 plus half of 5% is 0.025. Then I'm doing this for 2 years. Well, semi-annually for 2 years, that's twice a year for 2 years, so that gives me to the 4th power here. When I multiply that out, you get the final balance is going to be $2,207.63. The next thing we want to do is let's take a look at example 3. $1,280 at 13% compounded annually. So that's 1 plus 0.13. 3 years, that's once a year for 3 years. So that's going to be to the 3rd power. When you multiply this, you're going to get $1,846.91. Example 4, $15,600. This could be like a car loan. At 10% compounded semi-annually, so that's half a year. That means we're going to have to divide our percent in half. So that's going to be 1 plus 0.05. And this is for 3 years. So semi-annually for 3 years means it's going to be done 6 times. So that's my exponent. And when you do that, what you're really going to pay back here is $20,905.49.